Welcome back. Today we're going to work on perfect substitutes, and I'll just kind of provide a brief overview of what these are, and I would say that this is probably the easiest out of all the other utility functions to work with, probably because it's a very repetitive pattern and you just have to work through some of the problems to kind of understand the intuition. So yeah, with perfect substitutes, we want to know whether a consumer wants to buy all of good X, all of good Y, or anything in between. Like, okay, a few of X and a few of Y. So it really comes down to understanding or comparing the difference between the slope of the indifference curve and the budget constraint. So it comes down to these two, and that's why I kind of color coded these. My blue curves are my indifference curves, and the red line is my budget constraint. So when the budget constraint, or when the indifference curve is steeper, when the indifference curve is steeper than the budget constraint, we say that, okay, Bob is going to buy all of good X. And one thing that I like to do when I'm in the exam, I like to draw that picture, and I would draw like a little budget constraint, and then I would do those lines, because in my mind I like to have those lines, straight there, so I know that, okay, this person's going to buy all of good X. And how you can realize this is by knowing that, okay, my marginal utility of with respect to X over marginal utility with respect to Y, that is my MRS. That is my marginal rate of substitution, right? So if that is greater than PX, PY, that's my price ratio, that really just shows that, okay, wait, the MRS is these blue lines, right? The MRS, because that's the slope of your indifference curve, and the price ratio is this little red line, okay? So, okay, we see that the slope is steeper of the indifference curve. Okay, that shows that, okay, this picture matches my little expression over here, right? Now you're probably asking, okay, what does that tell us about Bob wanting to buy all of good X, right? One thing that you can do to kind of verify that is, if you manipulate this expression, you will end up getting this top expression, okay? And what that tells us, this is actually very important. This little thing is very important to know. This tells us that, okay, MUX over PX is our marginal utility, the benefit that you gain from each of good X. That is what this is, right? Because you're dividing it by the price. So that's the benefit that you get for good X. And this is the same thing, benefit that you get from good Y. Okay, wait, if you're getting more benefit from good X than good Y, then obviously Bob would want to buy more good X, right? So that means that, okay, if I keep buying more good X until you stop at where your income stops, right? You can't buy more than the income that you have in your pocket. So that is why we have all X. And in class, what we like to say is like our Alex and our Ally solution. Here's our Alex, Ally, and something else for here. You just have to know that. But yeah, so that's the intuition behind Alex, all X's. And now the same thing goes for our all Y solution, right? Where our indifference curve is flatter than our budget constraint, where our MUX right here, that is exactly what that says, right? Because this is our MRS, and this is our MRS, and this is our budget constraint. So that is what shows in our color coding. Plus, if you kind of manipulate it again, you would see that our marginal utility for good X is going to be less than marginal utility of good Y. Okay, if I get more benefit from good Y, then might as well just keep buying more good Y until I lose all my money. So that is kind of where it shows. Finally, here, one thing that is important to know is that, okay, here's where my indifference curve, the slope of my indifference curve is the same as the slope of my price ratio, or the price ratio. So here you would just say, okay, this is where MRS is equal to my price ratio. And the important thing to know is that, okay, when we're talking about anything on the budget constraint, that would also include our endpoints, okay? So Bob might actually end up also, liking are all X and all Y. Like that Bob might prefer all of X, all of Y, while also the MRS being equal to the price ratio. So that's something important to know that might pop up on an exam or anything like that. So problems now. For number 1, we have our utility function here, X was 5Y, and our price, so our price for good X is $2, price for good Y is $3. And so when we have that, our coefficients, we're just going to add that into our budget constraint, so it'll just be this. Right, we'll have our 2 here, we'll have our 3 here. That will equal to 120 because that's our income. Great, so that is our budget constraint. Okay, and our utility function already given to us. Okay, for an exam, you want to have these information out. You want to have your budget constraint straight up. You want to have your utility function out straight up. Now, now you're just comparing our price ratio and our MRS. The MRS is basically the, like MUX over MUY, right? And what that means is basically your partial derivative with respect to X divided by the partial derivative with respect to Y. And for perfect substitutes, I think that this is one of the easiest because the partial derivatives are just the coefficient in front of our utility function, right? So the coefficient in front of X here is just 1. Okay, the coefficient in front of Y here is just 5. Okay, great. So I know that my MRS is 1 over 5. Same thing here. The budget constraint, the coefficient is just 2. Coefficient is 3. 2 over 3. Great. Now all we're doing is just comparing price ratio versus MRS. Oh, okay, so this is like 20% for me, 63%, whatever. 1/5 is less than 2/3. So I know that, okay, my indifference curve is lower than my budget constraint. So it'll be like this picture. It'll be my all Y picture, right? Indifference curve lower and my budget constraints higher. I know that it's going to be an all Y solution. And how do I see that, right? One thing you can do is you just go back to your budget constraint, right? Because that is our constraint while this is our objective. This is what we want to kind of see. Like this is what we want to know. And budget constraint is our constraint, right? So we see that, okay, we're not going to get any X's, right? We don't want any X's. We only want Y's. Get rid of my X. I don't care about my X. We're left with 3Y is equal to 120. Y is 40, and we are left with 0, 40. That's my optimal bundle. For number 2, same thing. Okay, I just wanted to show the opposite scenario. This is my utility function. Here's our budget line, right? We're given a price ratio of 3 over 2 because that is our partial derivatives with respect to X and Y. And our MRS, 2 over 1, right? Because this is a coefficient of 1 in front. So we have 2 here, 3 over 2. Let's compare the two of them. I like to have my MRS in front when I'm comparing because that is my indifference curve. So I have 2, right? It's steeper. So my indifference curves are steeper than my budget constraint. Great. Which picture am I looking at? Oh, this one, right? Because here my indifference curve is steeper, budget constraint flatter. All right, so we're going to go all the way to all X solution. And okay, go back to my constraint, right? This is my constraint. Go back to that. We're not going to care about Y because we only want all X. We benefit from all X. So 3X is equal to 24. We're left with X is equal to 8, Y is 0. That's my optimal bundle. This problem, I actually really like this problem because I feel like it captures so many different equations and formulas and theories. So I really like this. So this one really just uses our main formula over here. Like this is our bang for our buck, right? Formula. So this is actually very important to know. Just knowing that expression and understanding how to kind of implement that in different problems is key to this exam. So, and key to learning economics really. So here we're going to kind of use the same intuition, right? Would Bob be better off buying more Pepsi and fewer pretzels? More pretzels and less Pepsi, or was his purchase, sorry, or I don't know, I guess, was his purchase already optimal? Here we're really just comparing the price ratio and the indifference curve and kind of manipulating the formula so that we end up getting this little expression. All right, so The marginal utility of Pepsi, I kind of went over this in the beginning of this video, right? That when it says that that's 9, right? Because this is our partial derivative with respect to x, we get 9. That is a benefit that you gain from one more unit of x, right? And the marginal utility of pretzels is 8, so that is the benefit that you gain from one more unit of y. So knowing this is very important too, right? That's your change in the change in your indifference curve. That is why that's where the slope of the indifference curve comes in, and that is equal to the MRS. So when we're kind of comparing the utility that you gain from the price that you have to pay, that really helps with the bang for your buck, right? So when you're doing 9 divided by the $3 that you have to pay for each Pepsi, that gives us 3. Again, 8, that's a utility that you gain from one more unit of good y. 8 divided by the 4, right? 4 is how much you have to pay for the Pepsi, or the pretzel, and that gives us 2. Now we're really comparing 3 versus 2. Wait, I'm getting more utility, I'm getting more benefit from the price, right, from Pepsi. So might as well just keep consuming Pepsi. And that is why Bob would be better off consuming more Pepsi and fewer pretzels. Okay, that is where our answer. That is what our answers would be. So yeah, so it's really easy when you kind of understand the intuition, and understanding these 3 diagrams is really helpful during the exam and econ in general. So thank you for watching.